For the dissolved oxygen test, it's important to find flowing water and to try to fill your water sampling bottle completely full with water. The directions suggest tapping the sides of the bottle to remove any air bubbles. And even going so far as to cap the water bottle underneath the water so that it's completely full. After you've got your water sampling bottle full of flowing water, it's time to add 8 drops of the manganese sulfate solution, which is MnSO4, and it's a pinkish solution, to the sampling bottle. We're gonna add 8 drops. And even though your sample bottle was completely full of water, because of the chemical reaction that's occurring, you should actually be able to fit 8 more drops of our next solution, which is alkaline potassium iodide with azide, to the sampling bottle. So we're gonna do 8 more drops of this. At this point, the surface tension is pretty high. My bottle looks like it's gonna overflow, but hopefully it won't. I'm gonna cap and mix and allow this double replacement reaction to occur and precipitates to form. So now we're gonna set the bottle aside and wait for the precipitates, the solid particles, to fall below the shoulder, the out part of the bottle. Okay, I waited until the solid precipitates have sunken below this sort of shoulder looking part of the bottle, and now it's ready to add 8 drops of sulfuric acid. After adding the 8 drops of sulfuric acid, you can see that the precipitates, the solid parts, are starting to dissolve. We're gonna mix until they fully dissolve, and then we'll add 20 milliliters of this solution to our empty reaction vessel. So you want to add to that 20 milliliter mark. Okay. Once you've got 20 milliliters of your solution in the reaction vessel, it's time to get ready to do the reaction. We are going to perform a titration with your water sampling bottle solution and sodium thiosulfate. So first you want to fill up this syringe or titrator with sodium thiosulfate by putting the syringe into the sodium thiosulfate bottle, turning it upside down, and pulling down on the plunger to fill up the syringe all the way with sodium thiosulfate. It may be helpful to have a partner help you with this step. And then we'll add 1 drop at a time of the sodium thiosulfate to your reaction vessel. And you want to swirl the solution after each drop to see if the color goes from yellow-brown to pale yellow. So don't drop all of the solution in at one time. Instead, go drop by drop, just like we did during our titrations, until it changes to a pale yellow color. After you've got a nice pale yellow color, which it could be helpful to hold your instructions behind the bottle just to show you that it is still yellow. It's not clear, but it's not the yellow-brown color we had before. You're gonna add some starch indicator to the reaction vessel. So just give this a good shake, and then we're gonna add 8 drops to the reaction vessel. And because the starch reacts with the iodine back from the alkaline potassium iodide we had in here, you should see a pretty purple color, which we're then going to continue to titrate with the sodium thiosulfate. So go back to your syringe, and we're gonna add 1 drop at a time, again, of the sodium thiosulfate until the solution becomes clear. So just kind of swirl as you go. Maybe one partner could swirl while the other drops. And once the solution becomes completely clear, that first drop that is completely clear, you're gonna stop. And again, using that paper as the background is helpful. So you can see it's starting to clear, but it's not fully clear yet. I think that's almost there. But again, holding up some kind of background to it will help you see if it's completely clear yet. And then we are gonna read, once you get it where you think it's completely clear, that you have fully titrated, you're gonna read the syringe, because remember, you started with your plunger here. You started with all of this 10 of sodium thiosulfate. So where is the plunger now? How much sodium thiosulfate did you use? And that will help you know how much dissolved oxygen is in your sample.